Heat is so important in our lives. But what is heat and where can we get it and how it moves? That will be our discussion this lesson, where we will start by how we can get heat. Next, we will see how heat is transferred. Then we will see some technological applications that produce heat. And finally, we'll look at the sun as the origin of most energies. So you feel warm when you rub your hand together in winter because the friction force between your hand generates heat. And the matchstick burns with contact rough surface because the mechanical energy is converted into heat energy by friction. Also, the nail gets hot when you pull it from a thick wooden piece because the friction of the nail with the wooden piece during taking it off converts the mechanical energy into heat. So let's see the experiment to prove the friction generates heat.
So what I'm going to do is be testing out if I drop these balls a lot of times, can I actually measure an increase in temperature? Is it true that the potential energy that you give something when you drop it does really get converted into heat? Okay, so I have here a bag of lead shot. So the reason I'm using lead is because lead has a very low heat capacity, and that means that it doesn't take a lot of energy to change the temperature of the lead. Okay, so first let's measure the temperature of our lead shot right now. So we've got about 60 degrees Fahrenheit. That's about 15.5 degrees Celsius. So now let's toss this on the ground and see if we can actually heat it up just by dropping it. Okay, so I have my bag of lead here. I'm gonna put it in a stronger bag here so it doesn't just split open, I lose my lead shot. So I'm going to throw this bag on the ground over and over and over again. And every time I pick it up, I'm giving the bag of lead more potential energy. So let's give it some drops. This is actually an exercise I made up called the first law of thermodynamics kinetic exercise. Okay, let's see if it heated up at all. Okay, so my bag broke open, but let's pour the lead in there. Let's measure its temperature. 63. It increased. 64. 65 degrees Fahrenheit. That's a 5-degree increase just by dropping it on the ground a bunch of times. That's crazy. So I wonder how high it could get if I just keep dropping it over and over and over again. Okay, here goes 100 drops raised over my head. Let's see how high the temperature increases. My arm's starting to burn. Left arm. Okay, let's see how hot that got. Definitely got me hot. Here. Okay, stick it in. What do we got? Better be a big increase. That was a lot of work. So we got over 65. Okay, so I'm going to say about 73 degrees Fahrenheit. So it went from 65 degrees Fahrenheit to 73. So an 8-degree temperature difference here.
So as we saw that increasing the speed of spheres and their friction during shaking leads to increase their kinetic energy and therefore the temperature rises. So the temperature is directly proportional to the speed of object and therefore proportionally direction to their kinetic energy. So here on this experiment, we will use a regular tap water with 25 degrees Celsius and the boiling water, and we will drop a nut in the boiling water. Then we will transfer the nut to the tap water. Notice that the temperature rises. So the temperature of water inputting the hot knot transfer in it is more than the temperature of tap water and less than the temperature of boiling water. So the temperature or the heat transfer from the hot knot to the cold water. So from that, we know that when touching two objects with different temperature, the heat is transferred from object with higher temperature to another of lower temperature, and the transfer stops with there is no difference in temperature. So from that, we can conclude that the heat is a form of energy which is transferred from a higher temperature object to a lower temperature object. And the temperature is the heat condition which determines the direction of heat energy, whether from or to the object when it meets another. The temperature is the heat condition which determines the direction of heat energy, whether from or to the object. Heat is transferred by three ways. First, convection, conduction, and radiation. So the conduction, the transfer of heat by conduction is the transfer of heat through some solid object from the part with higher temperature to the part with lower temperature. And that's why the cooking pans are made of copper and aluminum, because they are good conductor of heat and they have high melting point. Second, the convection. So the transfer of heat by convection is the transfer of heat in gases and liquid, where hot molecules which have less density rise upward, while colder molecules which have more density falls. So why the freezer of the fridge is found above the fridge? Because, as you see, the cold air that cooled by the freezer has high density, so it falls down, cooling the food in the fridge, while the hot air with low density rise up to the freezer to be cooled again. So because when air is cooled, its density increases, so it sinks to cool the food in the refrigerator, while the hot air with low density rise up to be cooled again. And also that's why the electric heater is put on the ground, because the hot air that heated by the heater have low density, so it rise up to warm the whole room, while the cooler air sinks down to the heater to be heated again. So because when air around the heater is heated, its density decreases, so it rises to warm the room, while the cold air with high density falls down to be heated. Last thing, the radiation. So the transfer of heat by radiation is the transfer of heat from a hot object to another without any need for a material medium through which heat transfer from the sun. So the heat comes to us from the sun by radiation. And that's, we wear dark clothes in winter to absorb most of heat energy coming with sun rays, and we wear light colors in summer to reflect most heat coming with the sun rays. So why the heat of the sun doesn't reach Earth by conduction or convection? Because there's a vast vacuum between the sun and the Earth. So heat is transferred by radiation through material and non-material. But heat transferred from heater to our body by convection and radiation. And heat is transferred from all sources of light by convection and radiation, but from the sun with radiation only. Now, let's see some technological applications that produce heat. And they differ in the energy resource that they depend on, the kind of energy resources, and the effect on the environment. So for example, we have the electric heater, electric water heater, the electric stove. They depend on electricity, which is renewable source of energy that don't pollute the environment. Next, the solar heater and the solar oven, they depend on the sun, which is a permanent source of energy and also not polluting the environment. But the gas oven depend on natural gas, which is non-renewable source of energy that cause polluting the environment, that pollute the environment. The coal heater depend on coal, which is non-renewable source of energy that pollute the environment. The sun is the origin of most energy on Earth. For example, its light converts into chemical energy stored in plant via photosynthesis process, and also stored in chemical energy in coal and oil. And it converts into kinetic energy stored in wind. How? The sun doesn't heat Earth by equal amount, so there will be places with hotter air and places with cooler air. So the hot air will have low density, so it will rise up, leave the place for the cold air to rush to take its place. So this movement of air, we call it wind, and as the air moves, it stored kinetic energy. And lastly, the light of the sun is converted into electricity by the solar cell, which then converted into light and heat from the lamp, kinetic energy in the fan, heat energy in the electric heater. So why the importance of solar energy in our life? Because it is the main source of energies on Earth's surface. And why the production of electricity from solar energy is preferred to that which is produced from burning of fuel? Because the sun or solar energy is a clean source of energy which doesn't pollute the environment, and it's a permanent source of energy.